Now in topic 3 of Unit 1, we'll be doing more arithmetic operations as we prepare for homework, our open notes quiz. All right, going on to our first slide. Remember, we're using a square to number these as part of our classwork. And we're asked to represent as a quotient of integers if the denominator is not a zero. Now we had said that if we have a value, let's say a in the numerator, and our denominator is 0, this is undefined. But if we have a quotient and our denominator is not 0, which type of number would this be? And we can spend a little time reviewing some of these as well. Well, this would be a rational number. Now we also mentioned rational numbers in their fractional form terminate or repeat. If they do that, that's considered rational. And then we have the irrational, like the square root of 2, which would not terminate and which would not have a repeating pattern. Now for number 2, we're going to have a vocabulary check and also go through the operation of dividing fractions. So take a moment, see what you can come up for words here. Now to divide, we're going to multiply our first term, which is 8/11ths, by the reciprocal of the divisor, which happens to be originally 4/7, but the reciprocal is 7/4. So we're going to do that now shortly. You're going to take this term, change the division symbol to multiplication, and take the reciprocal. Let's see what you get. So it looks like this to start. Now we can multiply our numerators, multiply our denominators, but we can also do some cross-canceling here. 4 will go into 4 once. 4 will go into 8 twice. So our numerator now is going to be 2 times 7 is 14, and 11 times 1 is 11. Now my next question is, what is the name, the general name of this kind of fraction when the numerator is larger than the denominator? All right, this is called an improper fraction. Now we can change improper fractions to what is called a mixed number. And just add these to your notes by saying, how many times does 11 go into 14? Well, it goes once, and then there's 3 left over that we put over our denominator. Now, if we have a mixed number and we want to change it to an improper fraction, we would take our denominator, multiply it by the whole number here, get 11, add 3, get 14 over 11. So a review and some background. Now as we go into number 3, we're going to look at some background skills. We want to get the prime factorization of 40. So we would write 40. And 1 goes into every number, and 1 is not prime. doesn't meet the definition of being prime. So the next, or the first prime number in our series is 2. So 2 will go into 40 20 times. This is even, so a 2 will go into there 10 times. A 2 will go into there twice, and we're left with a 5. So these are our prime factorizations of 40. Now we're going to do 56. 2 will go into there 28 times. 2 will go into there 14 times. 2 will go into there 7 times. Now both 5 and 7, along with 2, are prime numbers. So when we are asked to write a fraction in lowest terms, we might think of this as background and then write the 40. 2 times 2 times 2 times 5. And then the 56, 2 times 2 times 2 times 7. Now we're looking for factors of 1. Well, here 2 over 2 is actually a 1, so this becomes a 1. 2 over 2 is a 1, this becomes a 1. 2 over 2 is 1, this becomes a 1. So these are all 1s. 1 times 1 times 1 is 1 times 5 is 5. And then the same thing here, this is 7. So the answer to this is 5/7. Now you might have looked at this originally and said, oh, I can take a 8 out of there. 8 goes into 40 5 times. 8 goes into 56 7 times. If you knew that, then that would be a way. This is what they're featuring, so you see the background of what results then in 5/7 as an answer. Now some background for number 4, and you might make a crude sketch of this, would be nice. 1. When we think of the number 1, how many variations of 1 are there? Well, would you believe there's an infinite number of variations of 1? We can have 2 over 2, 3 over 3, 4 over 4, 5 over 5. We could have the square root of 2 over the square root of 2. We can have the letter E divided by the letter E. We can have X divided by X. All of these are forms of 1. Now, whenever we're dealing with fractions, in order for the calculation, the operation to be true, and if we're adding and subtracting fractions, our denominators must be the same, because a fraction is sort of a ratio, and we need to make ratios sort of equal to each other to get valid consequences. Okay, so one of the things here, if we are to write a fraction representing this, is what would our denominator be? That is, how many parts is this figure divided into equal parts? And the answer is 8. Now, how many of those are shaded? Well, 3/8. So that's the answer here, but we also gave you some background information. Now for number 5, we want you to write the example down. And then our first question about it is, what do we do first? Well, we deal with the parentheses, which is division. So when you do this division, what do you end up with? We'll pause. So this is going to be 1/5 times, the reciprocal of this is 2 over 1, which now becomes 2/5, and then we have to add that to 23/30ths. Now, as we just mentioned, in order to add fractions, you must have a common denominator. So between a 5 and a 30, what would be the common denominator? Well, it would be 30. Now, this one already has the common denominator, and I should clean that up a little bit here. That's better, and we now want to make this 2/5 into an equivalent fraction, but that has a denominator of 30. Now, we are allowed to multiply any fraction or any value by 1. That doesn't change its value. And we said that 1 has an infinite number of forms. So what form of 1 might we multiply 2/5 by so we end up with a denominator of 30? Think about it for a moment, and I'll ask someone. Well, this would be 1 in the form of 6/6. So 2 times 6 now is 12. And if we tease that apart, we'd get this, and the 6's would cancel out, and we would reduce that to 2/5. But we want a denominator of 30. So we're going to use the 12 here. Now, adding these together, we're going to get 35 over 30. Now, they usually want things in simplified form. Can you see something you can take out of each of these to simplify this? And the answer is yes. You take a 5. 5 out of 30 is 6. 5 out of 35 is 7. So the answer to all of this is 7/6. And now you've had some exposure to working with fractions. Now, for number 6, there's a number of ways to do this. You could convert everything to improper fractions. I like doing it this way, so this is a way we're going to feature. Now, we know we can add the 3 and the 3 and get 6. But right now, we can't add these fractions. But if we put them in a lowest common denominator that is the same, we could probably then add them. So what would you put here for a lowest common denominator between a 6 and a 4? Now, if you said 12, you are correct. Now, what form of 1 would we multiply this fraction by to get a 12 here? And if you said 2/2, that is correct. And what form of 1 would you multiply this fraction by to get a 12 of a denominator? And if you said 3/3, that is correct. And this would become 9. So now you add your 9 and 2 and get 11/12. And there is the solution. Again, if you have a question, be sure you're asking. Now, for example 7, take a moment to write this on your paper. This is sort of the big daddy of fractions here, a number of things to do. So I'll do this first step up here. We want to convert this mixed number to an improper fraction. So 9 times 16 is 144. Add 1 to it, this becomes 145 over 16. We'll get back to that. Now 8 times 7 is 56, and 1 is 57/8. And here this is just 9 9/16. Now, notice what we can do here. Eventually, we want to have a denominator of 16ths, because this one is 16ths already. This one is 8. This one is 16. So if we multiply this fraction in here by 1 in the form of 2/2, this denominator now becomes 16. And this numerator now becomes 114. So 2 times 57 is 114. So now, again, we want to keep our denominators 16. So we're going to go 2 times 145. 2 times 145 is 290. I have my calculator here, and 6 times 114 is 684, and then this is just a negative 9. So now what we're going to do is add these two together and then subtract 9. We'll let you do that too. So I get this. Now, they want the results simplified and as a mixed number. Now, how many times does 16 go into 965? So 965 divided by 16, it goes 60 times. And 60 times 16, and we got a little fraction left over, so 60 times 16 is 960. So how many do we have left over? So this is going to equal 60, which is 960, and then 5/16. So this was the big daddy of our work with fractions and took quite a time to get there. Now you'll probably have one like this on your homework, but this would be the protocol to solve it. Now for number 8, list that on your paper. It takes this many cups of sugar, and the caterer has this many cups on hand. So how many cakes can this baker make? Well, we have to take our total and divide what it takes for each cake. But these are mixed numbers, so we have to change them to improper fractions. So 4 times 34 is 136, and add 1 is 135/4. Now I'm going to change this to multiplication, and I get 4 times 4 is 16, plus 3 is 19/4, but I have to use the reciprocal now. So that is 4/19. All right, take a moment, see what you get. Now here the 4's are going to cancel out, and they just become 1. So we get 135/19. And if we divide 135 by 19, we get 7.1. Well, they're asking how many cakes can you make? Well, you can make 7 cakes, because out of the 0.1 you can't make a cake. Okay, again, knowing the background operations for fractions converting them from mixed numbers to improper fractions, knowing the rules of dividing fractions to convert it to multiplication. This is all part of our background work. Now for number 9, we have the fraction 7/12, and we're wondering if it terminates, such as 0.5, or if it repeats, such as 0.3. This would be 1/2, and this would be 1/3. Now, there is a protocol that we mentioned in our flipped classroom lesson for determining this. If the denominator only has factors of 2 or 5 or both, then it's going to terminate. But if it has other factors, 3, 7, whatever, then it's not going to terminate. So as we look at this, and we factor 12, again, you can do this if you'd like. A 2, you get a 6, a 2, you get a 3. Now we have two 2's, but we also have a 3. Now, this is also done after you've simplified the fraction. So what would be your decision here? Well, this is going to be a repeat decimal because of the 3 and will not terminate. Okay, our last one coming up. Now, for number 10, again, just by looking at the fraction, is this going to terminate or is this going to repeat? And if you're not sure, just do a primary prime number factoring tree. So 2, 8, 2, 4, 2, 2. So it only has factors of 2. So this will terminate. And then use your calculator to figure out what it would be. And 1, 8, 7, 5, and it terminates. Okay, this will wrap up our review. Again, we're getting ready for your open notes quiz.